It's actually better when the strength is less. Okay. So we'll start with a quick example. So I'll ask you a question and we'll give you some time to think about it. So discuss with each other, take 5 to 10 minutes and come up with a solution. Uh, so till now we have discussed a very, you can say, lame or fictitious example of Disneyland fireworks. So let's take a more practical and realistic example today. So say the ERP simulation and let's say what we have is we have two classes, faculty and say student. Both of these classes have a method called borrow book, let's say for accessing the library. They can have their own different definitions of the borrow book function, but the function is common in both the classes. Now, that's one. Let's say there is one more class called staff, but staff cannot borrow book. The borrow book function is only there in the classes faculty and student. Now, let's say a librarian wants to manage all this data. So you can think of a separate class librarian, or right now you can just think about your main function. So let's say in main, the librarian wants to maintain an array, and array is basically whosoever borrows a book should come in this array. Can you tell what kind of objects will be in this array? Either faculty or student, right? So either faculty objects or student objects will be in this array. Again, an example of a polymorphic array. So how will you use inheritance here to achieve this? Is the question clear? So you can iterate over this array and for every object you can call the borrow book method. Okay. I want all of you to think about it. Take 5 to 10 minutes. And I want to write down what the superclass will be, what you will extend. Write down a code in your notebook or in your lab. Okay, do you need more time to discuss or shall I go ahead? Okay. So one possible idea is what we have done in the lab so far. Since you want a polymorphic array of faculty and student, you create a superclass, use that superclass as reference. So what can be a valid superclass name? Person. Okay. So let's say we decide we'll make this superclass person, and you can make faculty and student extend person. You can create references of kind person and use that to build a polymorphic array as we have done so far. Is there any problem with this? So think about in terms of your project if you are doing, if there is some conceptual problem with this. Don't you think staff is also a person? So what if we also extend staff from person? Will there be a problem? If it has the method or staff doesn't have the method borrow book, right? And then someone can by mistake add either people of type faculty, student, or staff to this array. And we don't want staff into this array. So better we only extend faculty and student from, let's say, the class person. Okay. Let's add one more twist here. So let's say apart from borrow book, you have two more functions. So let's say faculty and staff, they can claim some kind of insurance from the institute. So they have function called claim insurance. Faculty has it and staff also has the same function, claim insurance, defined differently. Now let's say there is some other class, or in main, you again want a polymorphic array of all those people who can claim insurance. So this polymorphic array is for faculty and students who have borrowed book. You want one more polymorphic array, which is for faculty and staff who are borrowing claims. So how will you extend your solution now? Okay, again a superclass for faculty and staff. Can we do that? That's what our solution says. You want a polymorphic array of faculty and staff. You can have another superclass. Let's say, what will you name it now? I don't know the name. So some name, some superclass. And I'll say, okay, faculty and staff extends this. Suggest any name. Person is gone. Okay, employee. Okay. Now carefully look at this inheritance relationships here and see if something is wrong based on what we discussed when we initially started the actions. Java, that is not allowed. So what do we do now? So that is called multiple inheritance, which is not allowed here. So this problem, it's actually called deadly diamond of death in Java. Problem is simple that multiple inheritance is not allowed. Why it's not allowed is a small reason. So if you have two classes A and B here, both of them have their do stuff function, right? And a class C is here, which is extending both of them. So basically, it's Java says you can't have both mother and father. You can only be a single child. So if class A has a do stuff function and B has a do stuff function, class C will be confused. If you call do stuff, which ones to call? So your father and mother are so different, both are telling you different things to do. The child is in problem. Right? So this is not allowed here. Okay, so coming back, what do we do now? Do you have any solution for this? And also, you see, logically speaking, faculty, student, and staff, they should probably be extending a single class. Okay. Uh, so if we go more logically into this, so you have faculty, student, and staff, let's say. What is more reasonable is you have some class, let's say called person, right? And all of these are extending this class because all of them are going to have some common attributes, name, gender, date of joining, etc., and some attributes of their own. Now, the problem is you want two polymorphic arrays, one for faculty and staff and other for faculty and student, and how to build these arrays, given that we cannot inherit anymore. All of them have already inherited one class. So what do you do now? So here is a different concept that comes to your rescue. So you can try doing this in Java. You can take two classes, try extending one class from both of these. That will give you an error. And I'll show you in a while. Okay. So what comes here is the idea of something called an interface. Interface is also a type of class, but if you remember about abstract classes, so interface you can also call it as a pure abstract class. That's what C++ calls it. That means it's a class which can only have abstract methods. Do you see how this will solve this deadly diamond of death problem? If class A and B, they are not classes, they are interfaces. Interfaces means they can only have abstract functions. They cannot have non-abstract functions. So anyways, A and B, they cannot define do stuff functions because both of these are going to be abstract functions and C can define it in whatever way C wants. So instead of making a class, we'll make an interface. And the idea with interfaces, you can, so you use the word implement rather than extend with interfaces. You can implement as many interfaces as you want. And it's very different from inheritance. You don't want any kind of either relationship to hold here. But you can still use the references of type interface, just like you were doing with superclass. So what you can do is for faculty and student, you can have one interface. For faculty and staff, you can have another interface. And then you can use the references of this type interface. That's all. So let's look at some coding to how to achieve this. So let's see all of it step by step. Okay, so our first solution was you can have, so you have class faculty. So right now I'm not writing any functions inside it. I'm just leaving these classes empty. You have class student, class staff, right? So you want a polymorphic array of faculty and student and faculty and staff. Okay, nothing inside it also now. Right. So the first thing that we discussed was maybe you can have a common class, let's say person. And let's try to do this. And we said faculty and student both can extend person, right? That was what we said. So let's see quickly if there's any problem with this. It works perfectly fine. The code will not do anything because there are no statements that should run. Okay, no problem. Then we said that you can have a class. Let me make it capital P, employee. And we said that staff and faculty can probably extend employee. That's where we discussed is the deadly diamond of death problem. So if you say it extends employee, that is fine. But how do you make faculty extends employee? So let me try doing that here. So now faculty is trying to extend both person and employee. Do that, you see an error, right? Now we'll do a small change. Instead of making person and employee as classes, we'll make them interface. And instead of the keyword extends, we use the keyword implements. Do this now, there is no problem with this code. So generally, when you talk about interfaces, they are sort of a loosely coupled relations. And interfaces, you generally don't name them like superclasses. So they don't need to maintain any kind of ISA relationships. So usually interfaces are named something like, so let's say this interface here. So we should not call it employee. This interface here, we are making for those kinds of people who can claim insurance, right? So they are generally named as something like this, and enable, claimable. And inside this, you can define your function, claim. So although you are not writing abstract here, all the functions inside interfaces are by default abstract. You cannot provide a definition of the claim function here. Similarly, your interface person over here, this we define for faculty and students who can borrow books. So better to name it as borrowable, something like that. You can provide a definition here for the function called borrow book or borrow. Sorry, not definition, only declaration. Right. And so faculty is going to implement student. So you see, it is very much like that. If your classes have some kind of loose relationships and you want a polymorphic array, you should use interfaces. So as we were discussing, right, you cannot say bird flies and then you cannot say aeroplane extends bird because you want to use the fly function. Doesn't make sense. But what you can have, let's say you have bird, aeroplane, kite, all of them fly. So you're going to have a fly method in all of these classes. To force them to have a fly method, you can create an interface called flyable. And all of these can implement that interface. There is not necessarily any kind of ISA relationship. Now what you can do, just like your superclasses, you can create references of type borrowable, claimable, make these polymorphic arrays. So can you try to complete this code? It's mostly done. I'm coming. So rest of the things are exactly the same what you have done in the previous labs. Interfaces have a few more rules with them. So just like superclasses, you cannot define any kind of data members here. Even if you put some data members here, they will be static and final. Basically, no subclass can change those data members. They are purely for providing this kind of functionality. So we'll see more example of interfaces after Minder 2. We'll stick to this one. And now you can consider it like sort of a superclass, but it provides multiple interactions. in a net package traffic because these are abstract functions you need to implement and then just go ahead and create polynomial arrays. Generally, the interfaces that you will see in Java will simply be like this. They are called functional interfaces. They'll just have one undefined function, and any class that implements its interface should provide a definition for that function. That's all. While you're implementing interfaces, you can also still extend one class. So just to show you what you can do is, as we were discussing before, all of these are persons. So you can have a class called person here. And they can still extend person. So you can extend only one class, but you can implement as many interfaces as you want. That's all we are done for today. Today's class. Today's lab, please come with some loose sheets. There will be a submission. Some reason I think it means 8 to 10. This can try. So let's say in what minimal way can we complete this? So let's just compile it and see what happens first. So you see a lot of errors here. It says faculty is not abstract and does not override abstract method borrow in borrowable. So what is happening here? Borrowable is an interface, right? An interface, whatever method you define is abstract. So this method borrow over here is abstract. And any class which is implementing it now should provide its definition, or should itself be abstract. But all our classes here are concrete. So you need to provide a definition for this. So let's do that. So this is faculty. It can have a function called borrow. And you can just for now put a simple print statement here. That's all. What other function you should have here? Claimable is also an interface which faculty is implementing. So you should also define the function claim. And you can say done. So this is completed. Okay, what should we define in class student? Both of these functions or which one? Borrow, right? Only borrow is required. So here only borrow, and in staff you need only claim. Right. Done. So functions are defined properly here. Let's go back. Okay, so there is a small point here. So when you work with interfaces, we'll talk about its reason later when we talk about packages. So you need to explicitly put that all of these functions are public. Let's check. Okay, so okay, so I should say class Java main, right? Okay, so how do you make now polymorphic arrays? That we have discussed, right? Simply the way that you have been doing it till now. So you can make a few students and a few faculty. So you can say student S1 equals to new student. I don't have any constructors or anything right now. So I'm just creating with the default constructor. So say 3 students. Three faculty. It's always good to check it whether anything is wrong with what we did. Yeah. Okay, now what you need to do is create polymorphic arrays. So you can uh, create one for. So the type of your array is going to be borrowable and claimable. Right? We have references of type borrowable and claimable. So you can say borrowable B. So let's put 3 people here. Yeah. And okay, let's do it only for borrowable. For claimable, you can try to do it. And now you can go ahead and put these values here. So borrowable can hold students and faculty. So you can say S1, B of 1 equals to S2, B of 2 equals to F1, let's say. Right, and let's check. Let's try to make it T and see what happens. So T is a staff. So we are trying to put a staff type of object in borrowable. Try to do that, you get an error. So your borrowable array is specifically for student and faculty because these are the classes which are implementing it. And then you can just iterate over this array. That's all. So the point is you can further customize this code by providing faculty and name students, writing that in the borrow function. All that can be done. But this is the major idea that now you can use references of type interface. Now at least to try to write the second array which is for claimable. Right? Well, it will work in exactly the same way. So this is a polymorphic array. You can also use it for a polymorphic function like we discussed yesterday. Exactly the same. One more question, the answer to which we discuss after mine. So I'm just posing the question here. So when we are talking about all these polymorphic arrays, so one thing that we have learned so far is you can modify your code and make this array to hold any kind of objects. And now we know that interfaces are there. So you can use that in complex ways. But the question is, so let's say you have student and faculty, and now you want an array which can hold a few students, a few faculty, let's say a few kites, a few animals, and whatever you want. But it can also hold some number, some names, let's say some decimal values. So how will you do that? Object? Object of what? So you can create an object reference. Object is a superclass of every class. Superclass of every class. But what do you think? Are these objects? How do you deal with that? So how do you put these simple numbers inside this array? You can do that in Python. See again the idea of Python is that you can literally dump anything here. NumPy array, pandas, data frame, 1 to 3, even a list itself, dictionaries, anything. So how do you do that here? If you look at simple numbers, 1, 2, 3, or characters or double types, they are not objects. So that's why it's a very common interview question where they ask you, is Java a purely object-oriented language? No, it is not, because not everything is an object. You still have primitive data types that we initially worked with. So if they are not objects, how do you put them in an array? Along with others. That we'll talk about after migrants. Okay, we are done. We still have 10 minutes. So if you have any questions or any suggestions for today's lab, you can go ahead and discuss. So we'll meet in lab today and we'll solve the practice questions. And if you have any questions, so I'm not going to like centrally discuss every topic, but if you have any questions, you can just call me and you can ask me to discuss any topic again. I'll do it on a so have you studied demand paging in OS? On an on demand basis, right? Not centralized. So you solve them. If you don't know what to do, you solve them. If you know that there are all topics that you understand, but one topic which you are not getting, we can discuss that. But the major idea will be to solve the practice questions, because I know otherwise that's not going to happen if we don't do it in lab. How many of you have opened a practice sheet and solved, let's say, 2 questions? By two, I mean at least two.